screen, you see question number 1. Whenever Susan with a Z sees a bag of marbles, she grabs some. She grabs. She has a bag containing 4 red, 4 green, 3 white, and 3 purple. So the total is 10. She grabs 5 of them. Find the probability of the following event. Okay, so she grabs 5. It's important. She has 2 green and 1 of each of the other colors. All right, so these are combinations. I think all these are combination problems. So the first combination is from the 4 green, you're choosing 2 of them. So 4 choose 2 times, and you want 1 of the other colors. So you want 1 red, so it's 4 choose 1 red times 3 choose 1 white times 3 choose 1 purple. So the first one is for green, the 2 green. The next one is for red and then white and then purple. And the order doesn't matter because you're multiplying. All divided by, you have 10 total and you're choosing 5 of them. So you have a calculator. I've got a calculator. We got to get each of these numbers. And I think it's under math PRB for that. This one says to give a reduced fraction, so we can't rely on a decimal.
So do you do NCR? Or?
Yes. But you got to put the number in first. So it's gonna be 4 NCR2. So actually, let me go down here so I can get. So this is the first number is 6. Sorry, 2 times 4 times 3 times 3 over 252. So we got 6 times 4 times 3 times 3 all over 252, and that's 6 out of 7. Wow, that's surprised, but 4 choose 2 is 6. Oh, maybe I've got those wrong. I'm sorry. That seems way too high. Yeah, 4 choose 1 is 4. Okay, well, 6 out of 7. We'll try it and we'll see if it's correct. It's not correct. Oh, did I grab the wrong problem? 4. Oh, I'm sorry. I really messed this up. There's 14 total. Why didn't I? There's 14 total. So that changes this number. That's 14. Choose 5 down there at the bottom. 14 choose 5, and that's 2002 down on the bottom. All right, so let me get new numbers for this. Yeah, so this is much totally different number now. It's 108 over 1001. 4 red, 4 green, 3 white, 3 purple. She grabs 5 of them. 14 choose 5. Okay, so we got that number. 4 choose 2. Okay. So the second number, 2, 1, 1, 1, they have to add up to the 5 that she's grabbing. So this should be correct. So let me try that answer. The first one seemed way too large, but this one seems much more reasonable. 1008 over 1001. I'm going to try that. And that did work. Okay. Okay, so I'm going to go to 4 because it's a continuation of the previous problem, and we'll go back into the other ones, but this one will be clearer for understanding. It's another marble, kind of this marble problem that they like. So I like to draw a little bag thing. So we got 4 red, 2 green, 5 white, 1 purple. Oops, I should put that next to each other. So we got 4, 2, 5, and 1. So the total is 12. So a total of 12. Hopefully I added that correct this time. Now she grabs all the red ones, but she's grabbing 8 of them. Okay, so this time she's going to 8. So to get all the red ones, she's got to choose all of the red ones. Okay, so that means from the 4 red ones, she's choosing 4 of them. But we have a problem. We have 4 left over that she has to choose from. And the issue here is that you have to be able to make sure you understand like how she's choosing the rest of them. Like we don't care whether she chooses the green, the whites. We don't care. We just know that she needs to choose 4 more. Well, she's got 7, 8 from which she can choose 4 more because there's a total of 12. She's going to grab all 4 of the red ones, but then 8 choose 4 means from the rest of the 8 marbles she's choosing 4 of theirs. So these 2 numbers here on the right side, they have to add up to what you're choosing, what you're grabbing. On the bottom,
Hello?
yep.
Oh, sorry. I thought you broke up.
No. Have you been hearing me? I've been kind of went through this explanation here. My internet connection is unstable. Huh. Well, let me. Do I need to run through this again? Because I don't know how much you heard or didn't hear.
No, it's fine.
Okay. Okay. So we're just going to get these numbers now. I'm going to write them out. 4 choose 4. I get that number. It would be good to check me because if I make a mistake, it'll propagate through the end of the problem. So 4 choose 4 is 1. Okay. 8 choose 4. 8 choose 4 is 70. And then 12 choose 8 is 495. So we're just going to reduce this 70 over 495. Okay, and that's 14 over 99. And that is correct. So we're going to do number 5 next. It's another marble bag question. And then maybe that's the last one. We'll see. All right. So so we got another bag again. She's got 3 red, 3 green, 4 white, 3 purple, 6, 9. So there's 13 total this time, it looks like. Okay, she grabs 8 of them, but she does not have all the green ones. Okay, so the way I like to do these, instead of the not, let's find the probability that she does have all the green ones. And then we'll do a 1 minus that. So if she has all the green ones, that means 3 choose 3. She has to get all of the green ones. There's 3 green, and she's choosing all 3 of them. But she's grabbing 8 total, so we've got to choose 5 from however many are left over, which is 10. There's 10 non-green ones, and we're choosing 5 of those. And then out of the total here, since we're grabbing 8, 13 choosing 8 of them. So this 3 and this 5 add up to the 8, the 3 and the 10 add up to the 13. And then because we're doing a not problem, we're going to do 1 minus this whenever we get the values for them. So we're going to get each of these values for the combinations, and then we'll multiply them together. So 3 choose 3 is 1 times 10 choose 5. That's 252 over 13 choose 8. Okay, 1287. Okay, so we got 1 minus 252 over 1287, and that reduces to 115 over 143.
I got 0.8. Well, 0.195, and then 1 minus that is 0.804.
Okay, it wants it as a fraction, so just be careful to make sure you have the ability to move between those two.
Okay.
And that is correct. Okay. I would suggest we keep doing the marble problems, 7 and 8. Just because we're kind of on a roll here with these, and then we'll go back and do the rest. Okay, so this one's asking for at least one green. Okay, so that means she could have one green, two green. How many greens does she have? Five greens. Three greens, four greens, or five greens. And if we had to do each one of these, that's really long. Okay, or what we can do is 1 minus 0 greens, because 0 greens is the exception here, the one that's missing, 1, 2, 3, 4, 5 included, and the 1 minus gives us the the other ones, because the total adds up to 1. So when you see like at least 1, you generally do this 1 minus thing here. So at least 1 includes all of these, but it would take a long time to do all of them, so we're going to do 0 greens. So the probability of grabbing 0 greens is as follows. So we've got another bag here again. It's 3 red, 5 green, 4 white, 3 purple, and the total is 8, 12, 15. Total of 15. So out of the greens, since we want to choose 0 of them, it's 5, choose 0. Okay, but we need to grab 7 of them. Okay, so that means out of the non-greens, which there are 10 of them, we're choosing 7. So there's 10 non-greens. That's 3, 4, 3. We're choosing 7 of them. Over 15, choose 7, because that's the bottoms is always just this one thing. It's however many you have and however many you're choosing, and then the top is how you're breaking it up. But then we got to do a 1 minus that. Okay, so 5 choose 0 is 1. 10 choose 7. Wish I had a faster. That is 120. And we got a 1 minus here. 15 choose 7. 6, 4, 3, 5. So we're going to do a 1 minus 120 over 6, 4, 3, 5. And that simplifies to 421 over 429. Okay, that was correct. And I'll move on here to 8, which is again another marble question. All right. Okay, so this is, she has at most 1 green. So that could be 0 greens or 1 green. At most 1 means it's less than or equal to 1. That includes 0. So this time, unfortunately, we have to do 2 of these and add them together. Or generally means plus in probability. Not always, but most of the time. So again, we got this bag. The bag's got 3 red, 2 green, 4 white, 1 purple, and a total of 10 this time. Total of 10. Okay, so 0 greens means I've got 2 in the bag. So out of those 2, I'm choosing 0. Oops, that looks weird. 2C0 times. Now from all the other ones, there's 8 total, and I'm choosing 6 because it says grab 6 of them. I'm choosing 6. So that's the 8 non-greens. I'm choosing 6 of them. Over, there's 10 total, and I'm choosing 8 of them. Plus. So the bottom is the same because you're still choosing 8. This time you want 1 green. So it's 2 choose 1 green times. Now I still have 8, but this time I'm choosing 7 of the 5. Wait. I'm sorry. I got some wrong numbers here. I'm not choosing 8. I'm choosing 6 down here at the bottom. I'm choosing 6. And then on the right here, so let me back up. So it's 2 choose 0, 8 choose 6. The 0 and the 6 have to add up to 6. The 2 and the 8 have to add up to 10. 2 and the 8 have to add up to 10. 1 and now 5. You're choosing 5 others. 1 green and then 5 of everything else. Okay. And you just got to get these numbers and then add them up. So let me do that. So 8 choose 6. So this is 1 times 28 over 10 choose 6. That's 210 plus 210. So this is 2 times 8 choose 5. 56. Okay, so it's 28 over 210 plus 2 times 56 over 210. So that's 2/3. Wow. Okay. Well, that worked out nicely. We'll see if that's correct. Okay, so we did like 5 or 6 of these that are marble problems. I mean, you're definitely going to get something like that on your exam. I'll go back to number 2. Although number 2 is some sort of like formula. I actually don't know what it is asking for. Let me snip it in. Number two. It says, suppose that a monkey is seated at a computer keyboard and randomly strikes the 26 letter keys and the space bar. So find the probability that's first 24 characters, including spaces, will be beware the ideas of March. Right. Leave your answer as a formula. So I guess I don't know. Oh, the Ides of March. Okay. I guess I don't really know. To me, there's like one way of doing this over there's 27 choose 24, but that's probably not what it's looking for. So I'm gonna have to seek some outside help on this one. I can't believe they give you questions like this. It's just very odd. Thankfully, this has been solved by people over and over again. Um, this one says this solution says it's 63 out of 125, but it says it wants a formula, so I'm not sure what to make of that. I mean, I don't think you'll get this on your exam because it's a static question. It will never change.
Mhm.
But I guess I'd like to try this 63 out of 125 and move on. Okay, so that's correct. Nope, doesn't like that. Okay, I'm gonna move on because I don't really know what to put there because it says formula. That means you're gonna insert some sort of characters besides numbers. We'll just move on to 3 here. Okay, in a New York State daily lottery game, a sequence of 2 digits, not necessarily different. So they're saying that you could get 0099 or whatever. Find the probability that both are different. Okay. So like we know that the both here, there's 2 numbers. This is the top number and the bottom number. So the total number of numbers in the sequence here, there's 10 that can be first and 10 that can be second. So the probability that they're both different, meaning like you can't get 0011 22. Those are all bad. Well, how many are good? Well, you can choose any number you want in the first position. But in the second position, like let's say you picked a 1, well the ones that you want to be different would be 0 and then 2 through 9. So there's 9 possibilities in the second position. That would be okay. And that corresponds with like this list here all the way up to 9, 9. There are 10 of these that are bad, and this 90 out of 100, 0.9 leaves out the 10 that are bad there. So the only thing that could change for you would be, well, I guess both. That letter both could be different. So we'll go 9 out of 10, and we'll see if that's correct. It is. Okay. Okay, so 6 has 3 parts to it. All right, the sad state lottery requires you to select a sequence of 3 different numbers, 0 through 48. So order is important here, okay? So 3 different numbers means that there's, 3 positions, 1, 2, 3. What's the probability of being a winner, okay? So for example, there's 48 that go in the first position. I'm sorry, 49. 49 because there's the 0 adds 1 to it. In the second position, because they're different, that means there's 1 less. We learned that in the previous problem. And then there's 47 in the third position. So the probability of being a winner means that you get this correct. So there's only 1 correct out of 49 times 48 times 47. Only 1 of those correct. So I'm gonna get that fraction and then enter that in, and hopefully that's correct. So we can move through the next ones. So this is 1 out of 110544. That's the first one here. Five, 4, 5, 4, 4, 5, 4, 4. More mistakes are made entering than anything else. 1 over 1, 0, 1, 1, 0, 5, 4, 4. Okay. All right, so that's correct. Oh, it grades the other parts. Well, that's annoying. Okay. If your sequence agrees with that in the drawing, okay, wrong order. So that means you get the right numbers, but in the wrong order. Okay, so like I think that's what the second one means. So let's just say the answer is or the right one is 1, 2, 3. Okay, what they're saying is, well, you're also correct if you had 1, 3, 2. 2, 3, 1, 2, 1, 3, and then like 3, 1, 2, 3, 2, 1. Do you see any that I missed here? So like same numbers but in a different order. So there's there should be 6 total, including this one, I think. I'm just trying to figure out if I missed it. I try to just switch the last 2. 1, 3, 2. Okay, and then we got to put 2 in front. So 2, 3, 1, 2, 1, 3, 3, 1, 2. Okay, so that's, see how there's 5 here. So to me, that's this next one. It's 5 out of the 1, 1, 0, 5, 4, 4.
Okay.
And then the last one will be just adding the 2 together. It'll be the 6 out of that. Okay, so that is correct. So the probably bet either here is you just add up the ones that you had. So it's going to be this 1 plus 5 out of 1, 1, 0, 5, 4, 4. That does look like it reduces. So I'll get that number for you. Oh no, get the wrong thing there. Parentheses. Okay, so that's that ends up being 1 out of 18424. 18424. All right. Okay, so a little slower today to get through one of these, but the only one I'm not sure about is number 2. I could spend a little more time on the internet to figure out what it wants, but you could also ask your instructor. Unfortunately, there's not like a try another one for you on that one. All right, so we're gonna move to 8.5. Oh, you have more sections due on Monday. Oh, maybe that was the following Monday. Okay. All right. I think these will go a lot faster. So let me snip in number one. All right, so find the indicated probability. So the indicated probability, okay, so the probability of A given B is equal to the probability of, let me get this right, A and B. Um, okay, I believe this is it. Okay. So this is a known formula. Like whatever the second letter is, it comes up top here, and the and is always in the bottom. You'll see this in class. So they want this bottom number, and they're giving you the one on the left and this one in the numerator here. So the probability of A given B is 0.1 equals 0.6 divided by the thing that you're trying to find. This is not right. This is not going to give us a number that's right. Sorry, I'm giving you a wrong formula here. Let me back up. Let me go look for it. Not clear. Conditional probability formula. I think I have these backwards. Yeah. Okay. That's why. Okay. Yeah. The formula is the probability of A intersect B over the probability of B. So the second letter is what goes down here on the bottom. These match, and then the and is always in the top. So that changes what we're doing here. The probability of A and B is what you're trying to find over the probability of B, which is 0.6. You multiply both sides by 0.6, and you get 0.1 times 0.6 equals the probability of A intersect B, which is 0.06. And these will all be decimals. Probably not too well. There might be some fractions. I shouldn't make those blanket statements. Okay, number two, new question here. This one's asking about a dice roll. All right. Find the conditional probability of the indicated event when two fair dice, one green and one red, are rolled. So you should assume these are six-sided unless they tell you otherwise. I'm going to just snip in the sample space of these. It's good to look at this every once in a while because it can easily be forgotten. So the sample space for two dice is coming in here. I'll snip this into new questions. See, there's 36 possibilities. Okay, but this time we look at the given. The given is key. The given is what reduces this 36 down to however many we care about. So how many add up to 5? Well, 4. Well, actually, I like doing it this way: 1 and 4, 2 and 3, 3 and 2, 4 and 1. So there's 4 that sum up to 5. Now, what you have to do is decide is the red or the red or the green. Which one's first? We're just going to assume the red is the first die and the green is the second die. So which of these has a 1 in the first position? Well, only one of them. So there's 4 total that sum up to 5. Out of those 4, there's only one that has a 1 in the first position. This one actually says you can enter a fraction or a decimal, but it says do not approximate. So they're saying give me the full answer.
Um,
All right. Next one is a multiple choice, and we'll just move past that because you can just look at it later for that. It's just a true false kind of thing. All right, number 4 is a problem you would definitely see on an exam. Probably something you've even seen in previous classes. So conditional probability. So conditional probability, whenever you have a table like this, it reduces you either to a row or a column. Okay, given that she's successful. Notice I don't even look at the first part, just given that she is successful. So that's right here. Given that she's successful. So there's 30 that we care about. That's our new sample space. The author is established. Well, that's 20. Because that's the number we care about. This is the new sample space out of the row or column total. Okay, so that becomes 2/3 for that. I feel like we've done some of these before. Maybe we're just grabbing values out of a cell or out of a table before. Okay, that is correct. Okay, so a bunch of they actually threw in a few more marble problems. Again, I don't understand why. I'm gonna move past that and just see if we can get some of these other ones done here. All right. So if two events are independent, the probability of A intersect B, which is what we're trying to find here, equals the probability of A times the probability of B. So you just have to multiply these two numbers together. Oops. 0.3. So that equals 0.09. But that's a definition. You definitely want to have that down for your test so you can remember that. All right. All right, up to 7. Do you have a test upcoming soon?
Oh, we just had one like the past weekend, so I think the next one's the final. There
Okay.
was supposed to be one like on Tuesday, but she pushed it back to like last week. I don't really know why.
All right. Well, okay. So we had this from the first problem I messed up on the formula. A given B is the probability of A intersect B, or A and B, over the probability of the second number.
Okay.
Or second letter, so that these match. These letters here, they match, because sometimes you can't remember which one goes where. A intersect B is 0.4, probability of 0.5. So 0.4 over 0.5 is 0.8. You can check that in your calculator if you want.
Okay.
All right, a couple more of these. All right, so we got kind of same thing here. You wouldn't necessarily write this from you'd write probability of A intersect B equals probability of A and B over probability of B, and you substitute the numbers that you do have. You have the left number, you have the numerator, but you don't have this bottom number. So to solve for this bottom number, you cross multiply 0.4 times probability of B equals 0.3, and then you divide. So probability of B equals 0.3 divided by 0.4, and that is 3/4 or 0.75. So it's really, you have to have that formula down and know that most of these problems, they give you 2 of the 3 values, and you find the other one doing that. 9 is the same. It's very similar. I'm just going to just put the answer in, and then we'll move to, why did they ask you? Oh, I see. Okay, so 10's actually a good question too. All right, so find the probability of B given A. So that is equal to the probability of A and B over the probability of the second letter, which is A. Okay, so we're trying to find this, and this is the first time where it's like, hey, we don't have 2 of the 3 values. We have just the bottom value. Because they're independent, the probability of A and B is equal to the probability of A times the probability of B. So we have those two numbers. So 0.1 times 0.5, that becomes 0.05. And that's your number up there up top. And this ends up equaling, believe it or not, 0.5. So just an additional step there, but that's a good question because it'd be easy to just multiply or divide the numbers and
Mhm.
be completely wrong. Um,
Okay.
all right, so we're 3/4 of the way through this one. The remaining problems are marble questions, like we've been doing, and then another kind of conditional probability thing that's a word problem. Would you like me to go through those or go to the next section?
Um, we can just start the next section.
Okay. 8.6. Oh boy. These are we should not jump into this section yet.
Okay.
Let's go back to the
Is it
previous
due
one.
tomorrow?
It is.
Okay. My schedule.
The other ones are all in Chegg if with different numbers. Well, actually, all these are, but you could always, if you have a Chegg account, you can see how to mix and match these, or you can obviously schedule again if you would like,
Okay.
whatever you want. Okay, so we're going to move to number 5. This will help to solidify what we did in the last section, I think. All right, so she's got bag contains 2 red, 3 green, 3 yellow, 4 orange. So there are 12 total. That's always important to get down correct. All right, she gets one of each color other than the pink, given that she gets the fluorescent pink one. What? Okay. Oh, there's one pink. I missed that right there. Okay. So there's one pink, and that means there's 13 total now. 2, 3, 2, 3, 1, 3, 4. Okay. Um, she grabs 4 at random. Okay. So given that she gets the fluorescent pink one. Okay. So that means for sure she's choosing one of the pinks. Um, okay. So that means for sure she's 4. All right. She's one choosing one. She's getting one of the pinks for sure. Okay. Um, and then out of the 4 others that she's choosing, she's uh, there's 13 total, so 12. She's choosing 3 of them. Okay, so this is your bottom. By the way, I did this out of order. So your bottom, because it's normally just 13 choose 4, but this time she has to get a pink, and that's what goes on the bottom here. The one pink, and then out of the other 13 or other 4 that she's choosing, 3 of them come from the 12 that are not pink. So that's this given. The given affects the bottom. Okay. And what's the probability that she gets one each of the other color? Okay. So we know she chooses a pink, one choose one. But then we know but she's choosing 4. Oh, one of each color other than, okay. This is weird. Given that she gets the fluorescent pink one, but she's only choosing 4. 1, 2, 3, 4. This seems impossible. Like it seems like the answer is 0. Because she's not grabbing enough. Let me practice another here and see what it says. Oh, it's not available. I'm going to try 0 and see if that works. It is correct. Okay. Um, maybe a lot of that was confusing because she has to choose. There's 5 colors, and since there's only 4 of, since she's only choosing 4 of, one of them is pink. That means you're only choosing 3 more. Well, there's no way to get 4 from 3, so that's why it ends up being 0. Um, I don't know. That's a weird exception. I don't like that, but 11 is like it. We'll see if it's a little bit more clear, because it's maybe it gives you enough so that you can choose it. All right. Okay. Given that she gets the fluorescent ones, this is just she's 4 at random. So again, it's 3 red, 3 green, 1 pink, 3 yellow, and 2 orange. So it's 6, 7, 10. So there's 12 total. 12 total this time. And um, she gets the fluorescent one. Gets the fluorescent. Okay. So that's again on the bottom here. She has 1 choose 1 fluorescent, and there's 11 others. So that's 11 choose 3, because that's the possibilities. Now she wants all the red ones. Okay. So that means out of the 3 that are left, she's choosing all the red ones. So that's 3 choose 3. 3 choose 3 for all the rest of them. Okay. And that's 4 total, because we're already assuming that. So hopefully that's right. So the top is 1, the bottom is 1 times. Then we got 11 choose 3, and choose K, and choose K here.
Why is it 3 choose 3 again?
So there's 3 red, and we want all the red ones. That means we have to get all 3 of them. So that it's if it said she gets 2 reds, we would put 2 there on the right, but we want all of them. All right, and so that's 1 out of 165. Looks like. Hopefully that's right. It is. Okay. All right. Last question for this particular assignment is upcoming here. I would ask for probably another explanation on the previous ones in class, because I don't if it's going to be covered, I didn't cover it in as much detail as needs to be done, but we'll see. So you can find that out. So the new question here: according to certain news polls, 70% agreed that it should be the government's responsibility to provide a decent standard of living. So probability of decent, we'll call it just decent, is 0.7. 47% agreed that it would be a good idea to invest part of their Social Security on their own. So probability to invest on their own is 0.47. If agreement with one of these propositions is independent, or agreement with the other, what is the probability that person agreed with both propositions? So this is an and. It's like this is A, this is B. What's the probability of A and B? And you know by now that you just multiply the 2 numbers together. Sometimes it really is that simple. But you got to, you really got to read into these things, or you end up, being sure. Round your answer to 2 decimal places. So that's interesting. So I get 0.329, I think 0.329. Yep. So it's gonna be looks like it's gonna be 0.33. Let's try that. All right, and that gets that. So this assignment's completely done. We will start something in 8.6. These are all Bayes theorem. These are the most difficult questions that you'll see. And let's see if I can find one that's a good place to start, because I've worked with some other students in this problems, and the first ones are very unclear. All right. Okay, so these, boy, where do we even start here? Okay, I think I can start this one. Okay, so we're skipping number 1 intentionally. So it says y1, y2, y3 form a partition of S. That sounds confusing, but what it is that there's kind of a tree here. There's like, okay, there's there's uh, y1, y2, and y3. Okay, and they give us some of those values. They actually give those values over here, so that's where it's actually kind of clear. Like, oh, that's 0.4 and that's 0.2. Well, what's y3? Well, it's all the y's have to add up to 1. Okay, so the y's add up to 1, so that means this one is 0.4 over here. Okay, now x given y1, so that's there's like x over here, x given y1. They're telling you that that is 0.9 according to the values there. They're actually doing a couple of steps here, so it's somewhat, because there's actually another path here at not x and not x that you don't care about, but the one we do care about here is 0.4, and x and then not x is 0.7. So the probability of y1 given x, okay, is this y1 value 0.4 that we care about over the partition space of these other numbers. Okay, so it's 0.9 plus 0.4 plus 0.7. Normally you have to calculate these values at the bottom, but they don't have you do that here. But they are telling you this, although I think we have to multiply here. Sorry, let me do a quick search on this question, see if I can verify this. I think we are. I think I'm missing a step here. I think we do have to multiply. I think the numbers go 0.9 and then we have to actually multiply these. Bayes theorem. Yeah, so there's a little bit more to this. We have to multiply the numbers here. So the one we want is this 0.4 times 0.9. That's going down this part of the tree here, and that number also comes down here. And then you add to it going down this part of it, because it could be 0.2 times 0.4, because that's also x, but it's the y2 plus the 0.4 times the 0.7. Okay, so let me get this value, and that'll close this out. That was really rushed, and I would not expect you to really have followed all that. But if we do another lesson, or if you see this in class, maybe it'll be clearer. But all of these problems are the same in this section. You end up doing this calculation where you have a number on top, and then usually two or three on the bottom. You do it over and over again here. So 0.2 times 0.4 plus 0.4 times 0.7, 492447. All right, and 0.4. Okay, so it ends up being 1/2. Well, that's shocking. Hopefully that's right. All right, let me try entering that, and then hopefully that's correct, and we can close out here. It is. Okay, so that'll do it for today's lesson. I'll send you the notes and the screen recording out shortly, and thanks again for scheduling. I'll see you next time.
Thank you.
Bye now.